Section 2.1, example 5, integrating with respect to y. Could we really do that? I don't know. Let's revisit example 2.4, which is just a previous example. Oh, wow, cool. Only this time, let's integrate with respect to y. Let R be the region depicted in the figure below. Find the area of R by integrating with respect to y. That sounds like fun. Okay, so could we integrate with respect to y? So let's kind of turn this on its side so we could see. Now we just have to find a function in terms of y instead of terms of x, but it makes it a lot easier here. Looking at this, we have like this top function. Let me see, if I turn it the other way, would it make more sense? Makes a little bit more sense. All right, so in terms of y, we're going from 0 to 1. I know it looks a little bit backwards, but remember this here is our x-axis. We're going from 0 up to 1 in this region. If we saw our little person here, like we did in the previous problem, we're looking at this graph here. If we integrate this whole area, oh no, we integrated way too much, so we have to subtract this area. So very similar problem to the first couple ones that we had in the beginning, but I think we would have a little bit more success with this one. All right, so with respect to y, we are integrating from 0 to 1, starting off first with our g of x, 2 minus x. Oh, wait, we're not integrating with respect to x, right? So that's going to be a big no. Let's do this one because that looks like an x. So instead of that, let's turn this function here in terms of y. So here we have y is equal to 2 minus x. We have x is equal to 2 minus y. So this is that top function there. So starting off with that, 2 minus y. And subtracting, what are we subtracting? We're subtracting this one, x squared. Nope, not x squared. It's going to be y equals x squared. X is equal to plus or minus the square root of y. All of the values here are positive, so it's going to be the positive version of this one. So let's fix that really quick. So square root of y. And we're subtracting square root of y. dy. All right, now we're looking good here. So let's see what the rest of this is going to look like. So still integrating from 0 to 1. We have 2 minus y minus, I'm going to write this one as y to the power of 1/2 to make it a little bit easier to differentiate or to integrate. Integrating 2, that's going to be 2y. Integrating y, that's going to be minus 1/2 y squared. Integrating y to, or the square root of y, it's going to be 3 over 2, nope, 2 over 3, y to the 3 over 2. Integrating all of this from 1 to 0, or from 0 to 1. Let's start off with integrating that, or evaluating at 1. 2 times 1 minus 1/2 times 1 squared minus 2 over 3 times 1 to the power of 3 over 2. We have all of that. We're subtracting us, evaluating it at 0. So 2 times 0 minus 1 over 2 times 0 squared minus 2 over 3 times 0 to the 3 over 2. This whole part goes to 0. And we are left with 2, negative 1/2, negative 2 over 3. So get it all over 6. 12 over 6 minus 3 over 6 minus times 2, 4 over 6. So negative 7 plus 12 is 5 over 6. Since this is the same region that we were integrating in the previous problem, it should match. Oh my God, everyone, we did it. 5 over 6 here, 5 over 6 here. So integrating with respect to the opposite function or the opposite values is still going to give you the same answer. actually a little bit easier in this case, right? So if you have any questions, please feel free to ask. Otherwise, bye.